So far we've been looking at limits, looking at how to do it, looking at a graph and finding limits as x approaches some value. We started looking at finding limits algebraically. So given a function, finding a limit as x approaches some value. And then at the end of last week, I gave you some tools on how to simplify limits that gave you an indeterminate form, 0 over 0. So I want you guys to take a minute and see if you can do these problems on this page. So first, let's actually, before you jump into all of it, how about pull up the chat and do not push enter quite yet, but in there, in your words, put what is a limit. And so I'm going to give you each like 2 minutes to kind of describe in your words in the chat what is a limit, and then I'll tell you all at the same time to push enter, and then that will come through. If you push enter, it automatically sends the chat. If you are watching this not live, then go ahead and think about it yourself, pause the video and write it down and see if you get the same thing. Okay, so it was awesome. You guys threw in what you thought that a limit was. Daniela says a limit is a y value that comes from the left and the right side of an x value. So recall, that's right. So when we're looking for limits, we're looking at, as we approach some x value, on the left and the right, it has to be the same value, but the value that we're looking at for the limit is the y value. And Jocelyn states that the y value of the function that approaches the x value from the right and the left side. So we looked at one-sided limits and the notation for that. But again, in order for a limit in itself to exist, the left and the right-hand side have to approach the same value. So good job. That was awesome. So I want to now you guys take a couple minutes and now do the next part if you haven't done so already. So finding a limit. There's 3 things that we can do to find a limit. We really have only talked about 2 of them. And so after 2, you see that A, B. Well, think about what you would do. What are some ways that you can solve limits that give you an indeterminate form when you first do substitution? So I'll give you like 1 minute to do that. And so again, go to the chat and write in there how you would find a limit. We'll come back and talk about it. Okay, so I'm just going to grab some of the comments from what you guys had said about what a limit is. So a set of functions from both sides of the function. One using a graph, factoring, and rationalizing. So, right, so one way that we looked at limits was we looked at the graph. Erase that. Really, the first thing that you should do, if we have it, and we have a function, then you should do direct substitution. And then if for some reason we did direct substitution, we had this rational function, we got 0 over 0, that didn't tell us anything. So we had to manipulate that function so that when we took the limit, we could tell what was going on. And so you had stated that factoring, that's the first thing I would try to do, is factor both the numerator and denominator. And if you can factor, then there should be factors that are like factors that will end up canceling each other out. And then you'll do direct substitution again. And then Melissa was saying you can rationalize either the numerator or denominator and then take the limit. So recall if we had a radical in there, then rationalizing, getting rid of that radical in either the numerator or denominator, depending on where it was helpful. And then I saw someone else put another way that we had talked about finding limits. And so let's just put that for number 3. And let's see if I can find it. Talked about making a chart and plugging in numbers to the left and the right of the x values on both sides. Very, very close. So let's just say plugging numbers close to what we're to the x value of the limit on the left and the right. Okay, so they have examples. There's examples below of limits using direct substitution where we were going to have to factor, and then one where we're going to have to rationalize. Okay, so we're just going to go over these quick examples, not all of them. But first, let's look at number 2, which says a limit as x is approaching 2 of the square root of 3x minus 2 under the radical. And so again, whenever we're doing limits, we're given the function, what you want to do is go in and do direct substitution. So wherever we see an x, we're going to plug in 2. And so going in here, we have the square root of 3. I see an x, I'm going to put parentheses, and then minus 2. Inside the parentheses, I'm going to go back and replace or put right in 2 where the limit is going to. So order of operations, simplify underneath the radical. That's like a parentheses. And so multiplication comes first. So that's 3 times 2 is 6, and then minus this 2. So we get the square root of 4, which is equal to 2. Okay, so that one just fell right out when we did direct substitution. So the next one, let's look at number 4. And this one says, we're looking at the limit as x is approaching -7. In the numerator, we have 2x squared plus 13x minus 7. And in the denominator, we have the quantity x plus 7. So again, try direct substitution. So we're going to go in, and wherever we see an x, we're going to plug in -7. Is there a question?
Professor?
Yeah.
Do you think you can go back to, I'm sorry for the noise, it's my baby. Do you think you can go back to number 2 so I can take a picture? I was trying to get something to write it on, and when I come back, it was too late.
Yep.
Yeah.
There we go. Got it?
Thank you.
Yeah, you're welcome. So number 4, again, you want to do direct substitution. So let's go in wherever we see an x. Let's put parentheses. So we have 2. Oops, I need the pen. So we have 2. I see an x. So I'm going to put parentheses. That x is going to be squared. So parentheses squared plus 13. I see an x. So parentheses minus 7 all over this x plus 7. So wherever we see that parentheses, we're now going to plug in what x was approaching, which is this -7. Oops, and I forgot down on the bottom there was an x, so I'm going to rewrite that with the -7. And so order of operations, let's simplify the numerator. Exponents first, so -7 quantity squared. So this is 2 times +49. A positive times a negative is minus, so minus 13 times 7, that's 91. Minus 7 all over -7 plus 7 is 0. So 2 times 49, that's 98. Here, -91 minus 7, we can combine those two if we want. They're both negative, so add them together, keep the negative, so minus 98 all over 0. So we get this 0 over 0, which is that indeterminate form. Oops, that's a D. So this is where we had to go and try to factor. So I noticed that there's a trinomial on top. It's a quadratic, meaning that there's a square. It's in the form of ax squared plus bx plus c. So the coefficient though in front of my 2 when I'm trying to factor is not a 1. So I need to be careful. I like to use what is called the AC method, where I rewrite my middle term with the two numbers that multiply to give me AC. Remember, this was in the form of ax squared plus bx plus c. So we're looking at what multiplies to give us a times c. So a times c in our case is 2 times -7, which is -14, and which adds to give me the value of b. My b value in our case is 13. So we're trying to think of two numbers that multiply to give us -14 and add to give us 13. Once we figure out what those two numbers are, we're going to rewrite that middle term with a sum of those two numbers. So those two numbers that work, that multiply to give us that -14 and add to give us 13, I see that that would be a a positive 14 and a -1. So we're going to go up here. Let's rewrite the numerator. So it's 2x squared. Instead of writing 13x, we're going to use these two numbers we just determined. So we're going to write it as plus 14x minus 1x, or just minus x, and then rewrite the last term, which was this -7. All over this x plus 7. So when we rewrite that middle term with the two numbers we found, you should be able to do this by factoring by grouping. So that's where you're going to group your first two terms together. So in our case, it's the 2x squared plus the 14x, and it didn't matter what order you wrote those two terms in the middle, it will come out to the same answer in the end. And then we're going to group the last two terms together. So in our case, how I wrote it was -x minus 7. So you're pulling out what the first two terms have in common. So notice I look at the coefficients first in front of the variables. We have a 2 and a 14. So both of those have a factor of 2 in common. Then look at how many variables. We have an x squared and an x. What they have in common is a single x. So I'm going to pull out a 2x from both of those terms, just the first two terms. And if I do that, I'm left with an x from the first term. And if I pull a 2x out of this 14x, I'm left with a positive 7. If everything goes right and you do this correctly and you pull out the right things and you chose those right numbers, we should get the same thing what's inside the parentheses after we factor out what they have in common. Well, I notice those last two terms are -x minus 7. It's almost the same as this x plus 7. There's just a negative that I need to pull out. So we're going to pull out a -1 here. I'm just going to write the one there because sometimes people forget about that. Usually you won't see it there when they're doing the factoring by grouping. And then if I pull out a negative one, then what we're left with is this x plus 7. All over x plus 7. So now in the numerator, that parentheses, that x plus 7 is the same. So you're basically pulling the parentheses out of both of those groupings. So we're going to pull out that x plus 7 from both groupings. And if we do that, notice that we're left with 2x here. And this is where we're left with a negative 1 here, so minus 1. Because we just factored that trinomial all over x plus 7. And notice we have common factor in the numerator and denominator. Normally I would bring down this limit. This is kind of just side work. I'm just going to write side work. And then, so let's pull down that limit as x is going to negative 7 now. Notice those x plus 7s cancel. And so now we can do direct substitution. I have 2. I see an x there. I'm going to replace it with negative 7. And then I have a minus 1. And so 2 times negative 7 gives us negative 14 minus 1. So negative 14 minus 1 is equal to negative 15. Okay, so there was the case where we got an indeterminate form. We had to go back and factor it so that when we did direct substitution, a number came out and we could find that limit.